Okay, everybody, welcome back to the R for Pharmacometrics class. I'm going to take the first minute or so and answer a question that was posed just a few minutes ago. And the question revolves around, why should we use R? What does it bias over SAS or other software? And I guess I'll first qualify that and say, there are plenty of other people using other software. S Plus is a good one that comes to mind. And just to get that one out of the way, the main difference between R and S Plus, aside from some graphics capabilities, the main difference is cost versus one's pay, one's not. So I would have an argument arguing maybe between, or nuances between saying R and S Plus. And as far as other software goes, things like SAS, there's lots of people out there also that use SAS as a back end to, say, non-mem runs and things like that. So I guess it's hard for me to say choose necessarily one over the other. I think our main thrust has always been to use R because it's very nice and easy to write packages for. I don't know that you can do that with S Plus because it's not open source. I'm not 100% sure. And SAS, I'm not a SAS user, so I can't speak for that. I know in the past SAS lacked a bit when it came to graphics, though things may have changed there. I know in general the programming for R is just simply easier, and I think the learning curve is a bit shorter. So I think that's probably some of the benefits to it. I would just, it's not, I can't sell you necessarily on R to use it. So that's kind of generally the answer. I think you'll gravitate towards one or the other, but I think we've found, at least, and a lot of other people who work in our field found that R is very easy to use and very reproducible. Though you can get similar reproducibility with things like SAS scripts and S Plus scripts. So that's enough about that. Okay, so let's go back into what we were learning from on Tuesday. We covered a lot on Tuesday, some of the initial data types within R, vectors, data frames, lists, matrices. So now what we're going to do today is learn a little bit about, now that we have a handle on what a vector is and what a data frame is, we'll look a little bit about how we might manipulate those objects once they're created. So what you can do with them in R. And the first thing I'm going to do then is pop on over to our server. That's compmetricinstitute.org, and hopefully everybody has at least tried to log in. I know there have been some issues with Internet Explorer, but I hope generally everybody else has tried to log in and has not had any problems, or if they had problems, let us know what they were. Okay, so this is the interface that we looked at last week and what everybody should see when they log into our Metrum Institute RStudio server. So where are we at? We're in section 1.5 for those of you following along in the PDF. And I'm going to take advantage of the fact that I've supplied all of the R code in the PDF to everyone in the basic mechanics.R script. And I'm not going to go ahead and actually copy things into the terminal window here by hand. I'm just going to go ahead and run them from above. So this will give you an example of how you might run things from a script you've already created. So in this case, I have the basic mechanics.R script open, and we're, I believe, at chunk number 13, or the 13th operation here, if you were going to look at these relative to the PDF. Okay, so Let's create some vectors, and let's talk about different ways we can create numbers and assign numbers. So in this first example, it's fairly straightforward. We've looked at something like this before, where I simply create a vector called A, and if I type A back at the command prompt, you'll see the numbers 1, 2, 3, 6, and 10. Now the other option that we can do is there's obviously different ways of creating a set of numbers. Maybe we want to create a set of numbers, say the numbers from 1 to 5. Well, there's a couple of different ways we can do that. We can use the little colon separator, to create the numbers from 1 to 5, or we could use a function called sequence. And using the function called sequence to create numbers from 1 to 5, probably oversimplification or overly complex way of creating them. Because sequence, as you can imagine, takes a number of arguments, and if we wanted to, we could see what those arguments were. Actually, we could have to do question mark sequence to see what the arguments are. And over here in the help, we'll see there's a number of arguments that you get from and to and by, length out. So saying just 1 to 5 is probably simpler just to either generate them by hand or to, and if for somebody, by the way, I heard a message here getting somebody having a problem logging in. Joe Hebert, our technological assistant here, will help anybody along with that. So I'm not going to be able to stop and do that today, but we'll either contact you via email or send you some comments here to try and get you into the website. So you can also, as I said, you could also use that sequence operator to create a sequence function to create more complex structures. So in this case, I'm going to say something like sequence from 1 to 5 by 0.5. So now it fills in actually 10 numbers, and it actually puts them in at spaces of 0.5. You can also do something where rather than telling it what numbers you want to start and end and what the increments are to be between, you can just tell it what numbers you want to start and end at and how many you want total. And this might be helpful if you are, say, you know where you want to begin and end, you just want to fill in the spaces in between. And in this case now, I said, give me numbers from 1 to 5 and make sure that the total output is 10. So then R goes ahead and splits it up with the appropriate divisions, basically, of 1 to 5 and splitting it into basically 10. Another function we could use, not unlike sequence, but a function called rep that's really for replicating things. In this case now, what we'll do first is we'll create a vector, and that vector contains simply the numbers 3 and 4. And let's say we wanted to repeat that vector a bunch of times. So what we could do is we could do something like the following piece of code and say, okay, I want to repeat D, which is my vector, and I want to do it 4 times. So D1 now represents, the numbers 3, 4, 3, 4 repeated over 4 times. And you could do that as many or as few times as you wanted. And you can also, obviously, we can actually combine a number of these things, right? So we can wrap sequence in a call to replicate. So in this case, what we're doing is we're saying, okay, let's first generate a sequence from 1 to 10, and then take that sequence and replicate it 4 times. And if we do that, basically what we see on the screen output is basically 1 to 10 replicated 4 times. You could think of numerous ways to do this. You could generate the numbers 1 through 10, 10 4 1s, 4 2s, 4 3s, 4 4s, and then sort them appropriately. And you could do it that way too. So there's lots of different ways you can do this, or lots of ways to tackle it. Okay, so that's kind of simply generating a vector, different ways to kind of generate a vector or repeat a vector. Now, what if we want to operate on a vector? So let's say that maybe we want to add together 2 vectors. So now what we can do is we can create 2 vectors. One is A, contains the numbers 1 to 5. B contains the numbers 2 to 6. Now we can do very nice addition, and it'll add the elements of A to the elements of B. So it adds 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 to come up with a combined vector. The other thing about R can be a benefit, can be a bane on your existence depending upon whether or not the code is problematic for you that you've done. R will replicate or recycle vectors of differing lengths to do what you ask. So in this example here, we're going to create a vector from 1 to 5, that's what's A, and then we're going to create 2 other vectors with only 1 value in each, B and C, and they each have the value of 2 and 1. And what we're going to say now is we're going to say, okay, take A, multiply it times B, and add C. Now, B obviously, B is a simple multiplication operation. Okay, fine, I'll just say, okay, I have 1 to 5 and I'll multiply it. So what this is going to do is it's going to take each element in A, multiply it by 2, and then add the value 1 to it. So if we do these, takes 1, multiplies 2, adds 1. Takes 5, multiplies 2, adds 1. Does that for each element of the vectors. So the key here is that it actually recycled C to be actually the length of A. So it'll actually recycle and reuse C again. You just have to be careful because sometimes you may not want to do that. You know, maybe you really wanted to have a one-to-one addition and maybe your vector C was just one length too short. And you don't really realize that. R doesn't give you an error, it just goes about its merry way and recycles it to get you to where you need. Obviously, in addition to multiplication and addition, you also have things like, you can do things like subtract, you can raise to a power. You can raise to a power in 2 different ways inside of R. For those of you used to working in something like Excel, you could say something like 3 raised to the power of 2, or you can just use a double star, and that'll give you the same answer. Also, the other common arithmetic functions like log, exponential, sine, cosine, all of those are available to you in R plus others. So just be aware that you have those available as well. Okay, so in addition to that, those functions of just bear with me a moment. In addition to the arithmetic functions and the other arguments, you also have summary functions. So let's talk about, let's do A. So you could do something like minimum of A, and it'll give you the minimum value of present in A. You can also do max. Or you can combine those together. There's a function called summary. And that gives you a whole slew of answers. So it gives you the min, the median, the mean, the third quartile, the max. In this case, it's not a very informative summary to use. It's only 5 values. But you can envision, and I'll show you an example later on in the class, where you maybe have a column of concentrations and you want to know what the mins and maxes are. You want to know what the medians are. The nice thing about summary, too, is it also spits out if there are any NAs in there, it'll tell you how many NAs you have. So, it may very well be that you think there are no NAs in a column. So running something as simple as summary on can give you back some general or basic information. So we talked a little bit about vector operations. Well, operations on data frames can be performed in a very similar fashion. By that I mean you can operate on a given column. So let's say you have a data frame that has a column of concentrations and it's milligrams per liter and you want to convert it to nanograms per liter. You could simply multiply each element in that particular column by 1,000. You could also multiply an entire data frame, all the columns by 1,000. Obviously, if they're all numeric, that works just fine. If they're not numeric, you're going to get messages from R indicating there's a problem. And when we talk about identifying columns, let me just pull the data frame together here first. It's probably easier to have something to start with. So what I'm going to do is run a little chunk of code. It's going to generate, basically I've generated here a data frame, and I've used a couple of tools we've already gotten today. So first of all, the function to generate a data frame is obviously called data.frame. And data frame takes arguments of the column names that you want to generate. So I'm going to generate a time column, 0 to 10. Concentrations, start at 0, rise, and then fall. And dose. And I'm going to replicate the value 5 11 times. So in as many rows as I have. So if I were to look at A, we could say look at A, and we can look and see its time, concentration, dose. And next week, Jim Rogers, the next one, will talk to you a little bit about plotting. But we might plot these if we were going to look at this for the first time, but the other thing you can do is we could just do a summary on this. So we can say summary A. And now this becomes a bit more meaningful. Not so meaningful for time or dose, because dose isn't very interesting, but for concentration it is. It gives you an idea of what the minimum is, the maximum, the mean, and the median. It gives you some ideas of what these are. Now, something to keep in mind is, imagine that this data set consisted of multiple subjects. What summary doesn't do is allow you to give this answer by subject. So summary says over the entire data frame, so over the entire column, give me these values. So you may or may not, you may want to know what the median concentration is per subject. And again, next couple of weeks we'll talk about how you might want to do that. And as I said, you could let's say that we had to change this concentration. We wanted to multiply by 100. Well, how might we choose to operate on that column? Well, we have to give it the data frame name, which is A, and then we could say $, and now we're looking for the column name, and that's concentration. And we say $, concentration, and we're going to say, okay, well, we could do something like this, times 100. And in fact, that's going to multiply our concentration column times 100. But what it didn't do, it didn't change our underlying data frame at all, because what we didn't do is we didn't assign it to anything. So we did the operation, and it did go ahead and multiply it by 100, but it didn't put it back in the data set. So if we wanted to do that, we have to make sure we fill in the left-hand assignment operator. So we say $, concentration, and to that we want to assign $, concentration times 100. Now in this case, we see nothing spit back out to the screen, but if we look at A, we now see that concentration has been multiplied by 100. Now, that's fine. That's all fine and well, and we actually wrote back over the concentration column, so we've kind of lost whatever value the concentration column held. There may be a better way, or there may be other reasons, there may be other ways that you might want to do that. Rather than writing over that concentration column, we could have generated a new column, and let's call it concentration 2, and said $, const times 100. So now we're taking the column concentration, multiplying by 100, and we're going to create a new column called concentration 2. And if we look at A now, we now see that concentration 2 is the same as concentration, but everything's been multiplied by 100. So a lot of times we'll also, we'll oftentimes keep around the original column, either maybe for QC reasons or for just making sure that whatever operations we did, sometimes we're not doing something as simple as multiplying by 100. We could do something more drastic. Okay, so now let's go back to the original column that we had, the original A data frame. So I'm going to go ahead and submit that piece of code again. So now I'll just demonstrate to you that in fact now we have the original A data frame. And I talked to you about the fact that if we wanted to, we could apply a multiplication across the entire data frame. So we could do something like this. We could say A2, and that is now going to be creating a new object called A2, is A times 5. Now if we look at A2 represents A, but with each column multiplied by 5. And as I mentioned before, you have to be very careful. This worked because we had all numerics. If we had characters mixed in here, this would have R would have given us an error message saying you can't multiply. It wouldn't have said you can't multiply. It would have given us something a little less informative than that, but nonetheless, it would have given you an error message indicating that didn't work, that you can't multiply numerics times characters. Okay, so now let's try another way of doing this. Let's create a vector, or a vector called MLY. And that vector simply contains 1 and 2. And now what I'm going to do is I'm going to say, okay, let's create a new data frame called A3. And you can, just something you can tell the difference here between creating a new column within my data frame called A and creating a new complete object. Because what I'm doing here, I'm not adding anything like, I'm not saying something like $, with a name after it. I'm actually creating a new object, and I'm going to say, okay, it's A times 3. It's actually A times MLY. Oh, I had a space in there. So I had a comma in there instead of an M letter. So let's go ahead and put M in there. So now this worked. Let's see what the result that it gave us. So it didn't do exactly what we wanted. What it did, this is an example of recycling. Basically, it took MLY is the vector 1, 2. So it basically took, it recycled it enough times to be able to multiply through step by step. So it said row 1 times 1, row 2 times 2, row 3 times 1, row 4 times 2. So it works. You just have to be aware of what's going to happen when you have a shorter length vector being multiplied by some larger some larger data frame. It's going to go ahead and recycle that through. So somebody asked the question of does the $ argument have the same function as in Excel? I guess to some degree it does. I mean, I don't want to contrast it to Excel. What I'd like to say is that you can use $ as a selector. So a $ time will let you select the time column that exists in the data frame A. To that end, I mean, the $ in Excel is similar in some ways, but just remember how it's used here. Okay, so one of the things that you might have had to done for your homework, but we hadn't covered yet or just talked about briefly, was the use of the subset operator. And the subset operator is this, is the open and closed brackets. Oftentimes it's used with a comma in there because what you're specifying is rows and columns. So let me talk a little bit about what that means. So now let's go back to our A data frame. We still have A here. So one of the things I could do, let's say that I wanted just 2 of these columns in a new object. So I could have said something like A2 is A. Now I'm going to subset and I'm going to use all the rows because my rows are blank. And I'm going to tell it which columns I want. So it says, basically what I'm saying here is I want to subset A, write it to a new object called A2. I want all the rows because I left the row operator blank, and I only want the 2 time and concentration columns. So if I do that and I look at A2, I now have time and concentration. The other thing to keep in mind here is that though I wrote A2 before, back in some previous code, I wrote something out called A2. I just overwrote that entire object so that when I assigned something new to it, it was new. The other way you could have accomplished this is by specifying the column number rather than the column name. So I'm going to write this to A3 so we can demonstrate they're the same. So here in this case, I'm subsetting, but I'm saying instead of giving me by column name, I want the first 2 columns. And in fact, it still gives you time and concentration. However, I would argue that more often than not, what you're going to want to do is you're going to want to specify actually the column names that you want. especially when you're talking about generating code, whether it be to do data manipulation or code that somebody's got to QC later. You just don't know if being very explicit in this case that you want the time and concentration columns makes it very clear that you want those two columns. If for some reason columns got moved around, these results could give you very different results. The other thing we can do is, in this case, we've selected columns. We could also select rows. Okay, so let's take an example of selecting a row here. So now I'm just going to create a new object called F1. I'm still working with the data frame A. That hasn't changed at all. And now I'm going to say, well, I'm going to select the first 5 rows and all the columns. So now what I've done is I've indicated here the sequence 1 through 5. That refers to row numbers, and I've taken all the columns. So now if I look at F1, it has just the first 5 rows in. Now obviously you can combine those together and do something like this. Now in this case I want the first 5 rows and only the concentration column. So now all I have, really what I have left here is a vector, because I've grabbed just one column. So now F1 is really what amounts to really being what's left really is a vector. You can also select those rows based upon some condition. So for example, I could say something like this. I'm going to go ahead and cut and paste this so I don't make any mistakes. So in this case, what I'm saying is, okay, I want to create an object called F3, and in that I want to take all the times that are less than or equal to 5 and all the rows. So if I hit enter, then there you go. Similar result. In this case, I got 6 rows instead of 5. But basically now I'm able to set up what I want based upon times. And you can imagine this becomes very, very powerful, mainly because you have the ability then, if you want to say, maybe you have a bunch of multiple dose data and you just want to grab the first dose that occurs within 12 hours. You could imagine using this time less than or equal to 12 and getting all the first dose data for a given individual. Okay, so the next piece that we want to cover, and this is really the last piece that we have to cover of the course material till I get to the homework example, is importing and exporting files. So when you're working with R, you obviously have to get data into R to begin any kind of manipulation or plotting, and you have to be able to get data out with R, oftentimes because we're using R really as a means to an end. I mean, sometimes we're doing the analysis in R. We might run, some kind of statistical model within R to get us an answer, but lots of times, many times, what we're doing is we're feeding data maybe from different sources into R. We're doing some manipulations with the data and then writing out a data set that might be used in some third-party program, maybe like NonMem or WinBugs or even, NonMem, WinBugs, WinNonLin, something like that. So R has the ability to read different data types. That's the simplest thing that you could possibly read in, and the best methodology would be simply ASCII text. What I mean by that is simply comma delimited or CSV files from Excel. R also has the capabilities of reading SAS transport files. SAS transport files being XPT files. There's a package called SAS export that you can use that's available from CRAN, the R website. There's also other statistical formats it'll read, things like Minitab and S+, SPSS. I haven't had a lot of experience with using those other functions. Primarily for our aspect of it, we read in SAS transport files or CSV files. Yeah, I do apologize for the audio. I got a notice here on my end that the audio was being lost. So hopefully you all have that back by now, and then you can start to hear me again. Okay, so I'm going to pull open another R script here that I have. and it's called import export.r. And this is really a R script that will allow us to read files in and out. And so I believe that we already looked at this, but let me just give you let's take a look at the arguments for read table. By far the workhorse function for reading in files in from R into R is read table. And then there's some variants of that like read.csv that are specifically for comma delimited files. There's quite a few different arguments here because knowing that files come in different formats, sometimes with things like comment characters in them, the R people have made lots and lots of different options here, and some of the main ones that we're going to be dealing with really, let me just pull up another little thing here. Some of the main ones we're really going to be dealing with when we read data tables in are the file, obviously that's the file name, whether or not there's a header, that might be the names of the columns, what the separator is, so is the separator, is it a comma, is it a space, if there are any row names or column names. Oftentimes I don't have row names. In fact, typically what I can oftentimes get away with is something as simple as specifying the file, and whether it's got a header or not, what the separator is, and then as is, and I'll get to what as is in just a moment. So an example of reading a file in, there's a file in your basic mechanics directory called data1, and I'm going to go ahead and that data1 file is a simple comma delimited CSV file created in Excel. I'm going to go ahead and read that file in, and we can just take a quick, if we wanted to know how big was that file that we read in, how many rows and columns were there. Apologize for the phone ringing there. Well, if we wanted to know that, we could use the function called dim, which is dimensions. And so it has 460 rows and 7 columns. And there's also a very handy function called head, which lets you look at the first 5 or 6 rows of the, if I give it the right name, the first 5 or 6 rows of the data frame. So if I do head on df1, what I'm going to see is the column names and about the first 6 rows. And we can see that this is generally probably some kind of a data set. I mean, we have an ID variable, amount, time, DV, type, and compartment. And now it might be valuable to do something like summary on df1. And now these were all typically read in. These were all numerics in this data set. So now it's starting to give us a summary that could very well be helpful in some cases. Obviously, summaries on ID may not be very, very helpful. But a summary on the DV column, which in this case is concentration, indicates to us that it goes from 0 to 64. The nice thing is there's no missing values. There's no NAs, so at least we knew that. So let's talk a little bit about some of these arguments in read table. First, we have an argument called header equals true. That just indicates to R that in fact there are column headers and that they should be treated as column headers. I'm telling you what the separator is. The separator is a comma because it's comma delimited. As is equals true. By default, when R reads a data set in with read table, it's going to tries to guess what the data type is for each column. And more often than not, it will read in characters as factors. So it'll create a factor level, a factor data type for any columns that are characters, which can create problems because, I mean, even your dependent variable column, your concentrations might have things like the letters BLQ in them or NA or a dot, something that's non-numeric, and then it'll go ahead and create that as a factor. A better way is simply to say as is equals true, and then what it does is it suppresses R's guessing basically of what your the data types are, and it says, okay, if it's not numeric, just make it a character. And characters are just easier to deal with, and you'll see that in the next couple of weeks if we have to convert something back from a character to numeric, or it's just easier to deal with something that's a character than it is to have to mess around with factors. And as I alluded to, there are also other variants of read table, such as read.csv, which is for reading CSV files. And basically that just has, what that does is it just sets a number of the arguments automatically. So the sep variable is automatically set in read.csv as a comma. So there's just certain things. Also, there's also something called read.delim, read.delim, which is again a variant or a subset of the read table arguments for reading space or tab delimited files. You can get the same functionality as I demonstrated here with read table as you can in read CSV, just by setting the arguments properly. And the other thing we could have done is I didn't show is if you wanted to know what the names of the columns were, you can just do names and the data frame name. And so there you go. Now it tells you, it spits out back to the screen what the actual names were. So CID, amount, time, DV, type, compartment. So as well as reading files in, the next thing you're going to want to do is write files out. So if we want to write files out, there's a function called write.table. Write.table takes a similar set of arguments. X is basically the R object you want to write out, because in order to write it out, it has to exist as an R object first. File, straightforward. File is where you want to write it to. R is also going to need a separator, so right now, inside of R, it's not delimited by anything because it's an R object, so you can tell it what you want it to delimit it by. So in this case, you can say separate by a comma. R has the ability, if this file already exists, to append to it. So you can say append equals true, and if that file exists out on your network already or wherever you're writing it to, it'll just tag on what you already have onto the bottom of the file that exists already. Quote just means that if it's a character, should I quote it or not? Because oftentimes, characters might be quoted by their software. Oftentimes we don't want them quoted, so we'll oftentimes say quote equals false. Column names just basically says, do you want column names to be written out, and do you want row names to be written out? Again, oftentimes we do want to write column names, but we don't want to write row names. Even though you don't think about it, if we do a head on DF1, there are obvious column names, and there are also row names. Each row has a number 1 through 6. So if you say row names equals true, it'll create an additional column when it writes it out that have basically the row names. Sometimes that can be helpful because row names don't necessarily just have to be numerics. It could contain other values. And then finally, one of the other arguments for write table we might use is NA. And what it basically says is, if there's any NAs in a numeric column, what do you want me to represent them as? If you don't give it anything, R will assume that you just want the letters NA written out. Otherwise, you can tell it here how you want NAs to be written out. Do you want it to be written out as a dot? Do you want it to be written out as, BLQ, or whatever you choose to have NAs written out as? So as I said, it's as simple as doing, we have a, let's see. So let's read in another data frame here called data2.tab. We'll go ahead and read that in. And the dimensions on that were 150 rows and 13 columns, and we can do a head on that. And we can see this case now, rather than looking at an input file, we might be reading possibly an output file, maybe from a non-mem run, something like that. Maybe what we wanted to do is we want to create a new column. We're going to get to the whole idea of writing this column out, but one of the things we might want to do is we might want to create add a new column. Here we're going to add a new column, a comment column. And we're going to use the knowledge that we have about replicate. So we say, okay, let's create a new column called C. There's not one that exists. Let's fill it with zeros. And as I'd said, replicate Before we would pass it how many times you want it to replicate. Well, here now we're going to say, well, replicate it to the length of the DD column. And length is yet another function that'll tell you how long a given vector is. So I could have stuck in here 150, or I can say, well, I know I want it to continue the whole length of the data set for a given column, so I just do that, and boom, I now have a new column called C that was appended to the end of the data frame and that goes the whole length of the data frame. Maybe also what I wanted to do is I wanted to move the columns around. Now I'm going to go ahead and show you. I'm using the methodology that I didn't recommend, which is numbers. I know that there's 14 columns, and if I didn't know that, I could say dim df2, and I know there's 14 columns. So now I'm going to move these columns around, and you're going to find out in later weeks there's other ways of doing this. In fact, we have some nice functions to do this in an easier way. But one way you can do it is you can say, okay, I'm going to use my element selector function. I'm going to take all the rows, and I'm going to say, okay, give me the columns, but give me the 14th column first, then give me columns 1 to 13. So if I do that, what simply I've done, I went ahead and I moved the 14th column to the first column. And I accomplished what I wanted to accomplish. And I did it without having to write all the names out, but again, it's kind of a dangerous thing to do because there's no guarantee that C column was the 14th column. And I just did ahead of that. So now let's talk a little bit, before we jump into the homework, let's talk about the write table statement. And so in that case, again, I showed you the arguments it has, very straightforward. Write table, I want to write out the df2 object. I want to write it to a file called new.csv. And if you look over here, we can see in my lower right-hand pane that new.csv does not exist yet. And if I go ahead and write that out, now we'll see that new.csv does exist, and it's basically it's the information that was in df2 written out as a comma delimited form with column names and no row names. Okay, so the very last thing we covered, actually we covered an additional thing we covered here today is how to run R from a script. So we actually ran R from a script they already created. Within the RStudio interface, you could also do something like file new RScript and start typing here, comment new RScript. And when you want to save it, probably want to give it a certain name, so we can save it as, in the MI205 basic mechanics folder, we'll call it new script.r. And now I see it showing up down here. And now that we have this new script, let's talk about one other item that you're going to have to do as you move forward through this class and into your use of R. R is built upon a number of libraries. And libraries you can think of are really just their libraries are packages, things that are add-ons to R that you can use. Maybe you want to use it to do plotting. And the way that you get at those packages, you use a function called library. And you say something as simple as library package name. Now there is no function called package name. So if I run that, I'll get a nice little message saying error, there's no package called package name. But if I were to type something like library lattice, and you'll notice I don't need quotes. That was really just to indicate that it's a name. If I type something like library lattice, it'll go ahead and load the lattice library. Actually, it's already been loaded. It's already been, it already exists in it. Let me try a different one. Library. This is a package that we've written ourselves called MetrumRG. And now this is an example of what happens when you, not all packages, but many of the packages will give you some information about what occurred. When I loaded the Metrum RG package, which is available to anybody out there, and you'll hear more about it in the coming weeks, it loaded a bunch of other packages, and then it indicated the version of the package that I loaded. Some packages will load with information, other packages will load with very little information. All the packages that you need to do our course already exist. You don't have to install any packages. You may have to run library package name at some point, but you don't have to actually install anything. On some of your own systems, there are ways to install packages, and I'll let that up. You can either do it through the interface here, through it for install packages, or you could type like install.packages and pass some information to it, and you can check what the help file is for install.packages. You won't have to do that for our course, but needless to say, there are packages out there. Okay, let's move into the homework that we had, and let me just refresh our memory to what the homework was. So we had to, I gave you a directory called problems, and the goal was to import a file called week1.csv, summarize 3 of those columns, min, max, median, mean of each column, create a new data frame that only contains 3 of the columns, and then create within the new data frame, create a new column called NID that's an exact copy of ID, and then finally write it out to a new CSV file called week1new.csv. Looking at this homework now, it's pretty straightforward and easy. If you tried to attempt it before we started this class, it might have been a bit more of a hassle for you, but let's go ahead and take a look at a script that might do this. Yeah, before I do it, let's take a quick, somebody asked a question, and let me refresh our memory. We have a data frame called A, and one of the things I talked about doing is subsetting A. So let's do this. So let's say I wanted to subset A for times less than 5. And somebody brought up the point that in fact I'm using a column here even though I'm referring to a row, and that's true. I'm using a column name. What I'm doing though is I'm using the column name and information about that column to help subset the entire data frame based upon a given row, based upon a given set of rows. So what I'm basically doing is I'm saying give me back the entire data frame A, because I'm not specifying what columns I want. But what I want is I only want the rows where time is less than 5. So it lets me subset the whole data frame on information based upon a column. It lets me subset the A data frame to given rows based upon information in one of the columns. So then what that gives me back is, that gives me the A data frame back where time is less than 5. So it is true, we're mixing here rows and columns in different places, but just suffice to say that that subsetting operator, that those open and closed square brackets, you're going to see used quite a bit in our course as you move through it. Okay, so let's take a look. I've written a homework R script, and I'll be supplying this to everybody. I'll give you this R script. I'll post this R script either later today or first thing Monday, so you have the answer for the homework. So the first part of the homework was to read a file in called week1.csv. I'm going to move this down. And so it was a comma delimited file, and the function is read table that you want to use. Now some people may have had some, I know if any of you tried this, depending upon where you unzipped your basicmechanics.r file to, where you uploaded it to, the beginning part of this path may be different. Some people put it in their home directory, which is home, and your username. Some people put it underneath the R directory in their home directory. So their first part of the path might be home, username, R /. But the balance of this path, starting with MI205, should be the same for everybody because that's where the file would have been unzipped to. So if I run this script, what should have happened is, well, I know what happened is, I read the week1.csv file in. Now, if the other thing we said is let's determine the number of rows and columns. Well, that's an easy one. I can just say dim week1, and it tells me, well, there's 50 rows, 6 columns. And in fact, it will spit some of those out to the screen. Now, just be aware, if your data frame gets to be too large, the RStudio interface has a limit to the amount of rows that it will output for you to look at. So I don't know what it is, but you'll basically get a message after you get to the nth row that basically says you've reached the maximum amount of rows that you're allowed to look at. So you can only look at so many of them. Truthfully, it's only helpful to start looking at rows and data frames like this when the data frames are small and there's not that many rows. Otherwise, you kind of get lost. So we've already answered the first part of the question. Import it and calculate rows and columns. Now I said, what are the minimum, maximum, mean, and median in each column? Well, I could have done something like this. I could go through and say, well, let's see what the names are first. Names of week 1. I could have done something like this. What's the min of week 1 ID? And what's the min of week 1 time? And I could have actually written these into a script and gotten all the answers. But probably easier than that is to simply use the summary function, which gives me the min, median, mean, and max for each of the columns in the data set. And in this case, sex, what you'll notice is that I did not supply as is equals true when I read this data frame in. So it said, I think sex is a factor. In this case, it guessed right. It treats males and females as a factor, so when it summarized this, it said, oh, I know that's a factor. It really doesn't help any to give you mins and maxes of a factor. I'm going to give you how many are in each category. So there's 20 females and 30 males. Now, the first thing you'll probably realize is that there really isn't 20 females and 30 males in this data set. My IDs only go from 1 to 5, so it actually doesn't do any intelligent counting. It just counted how many Fs and how many Ms there were. Now, so what's the other thing I have to do? Well, I wanted to create a new data frame that only contains 3 of the columns, ID, time, and concentration. So I'll use our subset operator. I'll say, okay, let's operate on week 1. We'll take all the rows, but only those 3 columns, and we'll write it out to week1.b. And if we do that, we can take a look at the first couple of rows of week1.b and demonstrate, yep, in fact, there it is. Week1.b has the first 3 columns. And then I said, okay, now that we've done the first 3 items, how about let's create a new column called NID with an exact copy of ID. And that's a very simple one. We just take ID and assign it to a new column, NID, and it'll generate it on the fly. And bingo, it's done. And then finally, the last part of the homework was, let's write out this data frame that I created with up here in step 4, which is basically the week 1b data frame, and call it week1new.csv. So simple, I'm going to write CSV. What I'm going to write is week1.b, and now because I'm using the right CSV, it knows that I want a comma delimiter. It knows that I'm expecting it to write out column names, but I don't really want it to write out the row names. It's not very helpful to me. So I can go ahead and write that out. Now, if I was grading homework and I said, and you didn't say row names equals false, there's nothing wrong with that. Maybe you did want row names in there, but the key steps here is that you give it for the file you want to write, you have to give it the actual path to where you want it to go. Now, the first thing you'll also notice here is that I didn't give it the actual argument names. I could have said something like x equals file equals. What I relied upon is the fact that R will do matching. So it'll do one-to-one matching with the argument it expects and the argument you give it. Again, not a good idea to do it on a regular basis because it's very easy to if you put things out of order, you don't get the right file that you want. So that was really the 5 steps for the homework. So nothing too complex, fairly straightforward. And hopefully for those of you, if you haven't tried it, I hope that you will give it a shot before the next class on Tuesday. Another question that just came out is, how do I save the information that's down here in the R console? If you're thinking about saving the actual code you wrote like that, you could simply cut and paste it up or copy it up to the script above. But what's going to happen is you end up getting these little pluses and things like that in here. The short answer is there's not a nice clean way of saving the information that's down here in the console out to a file. And I would argue that you probably don't want to. What you want to get in the habit of doing is, even if the R script is blank, you want to get a habit of working from a script, even if it's really basic things. You want to get in the habit of just having a blank script open at the top and doing what you want to do, submitting them down below, so that then you have you can reproduce what was done. There's no reliable way to save what's down in this console window out to a file for use later. So yeah, I would encourage everybody when you're doing this, even if you think you're doing basic things, is to open up a script or open up a new script and then start using it. In fact, I would even go so far as to say that when you open it up, you should save it first, so that you don't lose, if you get disconnected for some reason or something happens like that, you don't lose the information that's up on the screen. Okay, well that pretty much takes us right to the end of the class. There's a few, I don't have any more material to cover. Typically weeks won't be like this. Usually you'll have a lecture in the first hour, and oftentimes it'll just be lab rather than kind of a lecture the whole way through, which in this case the lab was only the last 20 minutes. So anyway, feel free to go if you want. I'll be around for the next 3 or 4 minutes if there's any questions. And if you come upon any questions of the homework or anything like that, just people have been using the forum, please use the forum to post. Yeah, actually, good question. Somebody asked how I change a column name. So let me bring back a data set again here. Let's bring back a data frame here. I'm going to use this A data frame again. So now I have A. What I would do if I wanted to rename, there's numerous ways you can rename a column. You can do something, the names of A are time, concentration, and dose. You could do something like this, names A, and then you supply it the vector of names, like TAD, concentration, dose. That then renames, that renames time to TAD. I typically, oftentimes, what I'll do is I will simply, if I really just want to rename a column, sometimes what I'll do is do something like this. I'll say A $TAFD, A $TAD. So my first step is I create a new column that looks exactly like it. Then I take the old column and assign it the null value. And that basically gets rid of that old column. There's even more fancier ways to do it that aren't necessary to go into today, but the numeracy, there's lots of different ways to rename a column. Mainly what you want to do is make sure that whatever you do is traceable, that you can, that somebody else following later on can see how you do it. And I just showed how to delete a column. Somebody wants to know how you delete it, and actually you can just write null over that column. So I could have said something like $const and assign it null, and that blows away the concentration column. And somebody actually asked if they're not using the R server and they're working on, say, a home computer or somewhere else, can you still import and export files the same way? And the answer to that would be yes. The functions of read table and write table that we talked about today, this read and write table have absolutely nothing to do with RStudio itself. It really just has to do with the operating system that you're dealing with, because the path and where your data exists. So I'm able to find out, I know that my data exists under home.billk, home/billk. So if you were to unzip that basic mechanics.zip file somewhere on, say, a Windows laptop or on some other laptop, you just got to make sure that you're working in the right place and that you pass it the full name to the directory, the file that you want to read in. So the short answer is yes, you don't need RStudio to read these things in. You can do this from a home computer or from a laptop or from a computer system somewhere else. Somebody's asking whether or not the RStudio that you download is missing this upload button. I don't know, actually. I don't use the standalone RStudio, but I will take a look at that and post something out to the forum later on today. I would say make sure that you've grabbed the most recent version of RStudio. And, geez, I would have thought there was a way to, well, actually, you know what? It wouldn't, come to think of it, if you're using a standalone RStudio that you've downloaded for use on your laptop, you don't need an upload button because there's nothing to upload. So no, it doesn't surprise me at all that the downloaded RStudio that you use as a standalone RStudio doesn't have that upload button. Because upload by default means you're uploading it from wherever you're living to the server that RStudio is running on. So if you're running a local copy of RStudio, there's nothing to upload to. So that's exactly correct. There is no upload function under files in the RStudio that's a standalone RStudio you can download from their website. Okay, that's it for today, guys. Other questions? I don't see any, but please post them to the forum if you have them. Otherwise, give the homework a shot, and we'll see you on Tuesday. Thanks, everybody.